So let's put it to a test. Okay, so for case-to-case observation, our analysis 4.8. So case 1, finding S in a given sequence of consecutive whole numbers with odd number of terms. So it is being given here that we are going to solve odd numbers, so we are going to use S equals to N multiplied by M. So the given number of terms is that 21 plus 22 plus 23. So the median is the middle number. So the middle number is 22. So we are going to distribute the following values. So our N is 3 multiplied to 22 because 22 is the median and it resulted to 66. Therefore, we can say that 66 can be expressed as the sum of two consecutive counting numbers. So for the next example, 75 plus 76 plus 77 plus 78 plus 79. So the number of terms is 5. So 5 is an odd number. So we are going to use the formula again, S equals to N multiplied by N. So distributing the following values, 5 is the number of terms, 77 is the median because it is the middle number. So we are just going to multiply it. The result would be 385. So therefore we can conclude that 385 can be expressed as the sum of 3 consecutive counting numbers. So now, for case number 2, finding S in a given sequence of consecutive whole numbers with even number of terms. So now we are going to solve for even number of terms. So the formula we are going to use is S equals to N multiplied to the quantity of M sub 1 plus M sub 2 all over 2. So the given terms are 21, 22, 23, and 24. So the median is 22 and 23. So substituting the given values, S equals to 4 multiplied to 22 plus 23 all over 2. So the result is S equals to 4 times 22.5 and multiplying it, S equals to 90. Therefore, we can say that 90 is a counting number that can be expressed as the sum of 3 consecutive counting numbers. Our next example is still an even number of terms. So we are still going to use S equals to N multiplied by the quantity of M sub 1 plus M sub 2 over N over 2. So the given terms are 75, 76, 77, 78, 79, and 80. So we can see that the two middle terms is the median, so which is 77 and 78. So we're just going to substitute the given values. S equals to 6, which is the N, because 75, 76, 77, 78, 79, and 80. So 6 is an even number. So substituting the medians, 77 plus 78 over 2. So the result for adding 77 plus 78 over 2 equals 77.5. So multiplying it by 6, the result would be 465. Therefore, we can say that 465 is a counting number that can be expressed as the sum of 3 consecutive counting numbers. So from the given examples, we can say that numbers can be expressed not just in one but more ways to find if it is a sum of consecutive numbers.
We have here our case-to-case observation determining if a counting number can be expressed in specific number of terms. We are going to have even number of terms as our example or as our illustration to suffice or to fulfill our case or to fulfill our objectives. For our case number 3, we have the sum of consecutive counting numbers is 10. Can 10 be expressed as a sum of 6 and 4 terms? Since there are 6 terms, we are going to use X. We are going to solve first for the 6 terms. We are going to use X plus 1 plus X plus 2 plus X plus 3 plus X plus 4 plus X plus 5. And our median is we are going to obtain the median, or we are going to get the median, which is the first and second median, x plus 2 and x plus 3. So we are going to use the formula for even number of terms. We have s is equal to n multiplied to the quantity of m sub 1 plus m sub 2 divided by 2. So we are going to substitute all the given. 10 as the sum, and 6 as the number of terms, and x plus 2 plus x plus 3, which is our m sub 1 and m sub 2, divided by 2. So we will now obtain x is equal to 6 multiplied to 2x plus 5 divided by 2. We're going to cancel 6 and 2, so we will have now 10 is equal to 3 multiplied to 2x plus 5. So 10 is equal to 6x plus 15. So 6x plus 15 is so we are going to find the additive inverse of 15. So 10 minus 15 is equal to 3x. So 10 minus 15 is equal to negative 5, which equals 3x. So we will divide both sides by 3 so that x will remain. So we will have negative 5 over 3. The next given, which is 4 terms. Since we have 4 terms, and it is even, 4 is an even number, then we are still going to use the formula we used earlier. The s is equal to n multiplied to the quantity of x plus 1 plus m sub 1 plus m sub 2 divided by 2. Since there are 4 terms, our median would be x plus 1 and x plus 2. So we are going to substitute all the given, which is 10 is equal to 4, multiplied to the quantity of x plus 1 plus x plus 2 divided by 2. So 10 is equal to 4 multiplied to 2x plus 3 divided by 2. So we are going to cancel 4. It will be 2, since it is like dividing 4 and 2. So we will now have 10 is equal to 2 plus, we will now have 10 is equal to 2 multiplied to the quantity of 2x plus 3. Then distribute 2, we will have 4x plus 6. Then we are going to find the additive inverse of 6. 10 minus 6 is equal to 4. So we will 4 is equal to 4x. Now we are going to divide both sides by 4 so that x will remain. So our x would be 1, and it is a whole number. We are going to explain further later in our discussion what is the implications, or what is the conclusion, or what is the case all about.